Hi there, class. It's just me, Mr. Wee. So it was unfortunate, but my first video I still put up, so you can kind of watch visually what happened, but it didn't have any sound. This is for 2018, 2019 for the very first introductory video in section 1.1, but I'm going to kind of go over just really quick, maybe a sample problem that kind of encapsulates what we talked about in class. So let's take a look at a sample problem with the circle. And also, I have one more topic to cover after this. So like one more like a type of problem that we can kind of look at. So let's first look at a circle with a radius of 5. It is centered not at the origin anymore, but it is centered at -3, 1. It passes through another point, a point at 1, 4. Please find an equation. Whoops, that's an equation for the line, the only line that is tangent to the circle at 1, 4. Okay. So just a few things to note. We're in section 1.1, which is linear functions. Before we start this problem, please remember linear functions, there are two ways to write linear functions. You can write it y equals mx plus b form, which is slope intercept. If you don't know why, that's because the slope is right here. Whatever number is in front of x will be your slope, and the b tells you the y point of your intercept, your y-intercept. So this is slope-intercept form for the line, okay? And then you also have y minus y1. This y is stagnant, does not change. y1 can be replaced by any y point or y coordinate of a point times, or is equal to the slope times x minus x1. Again, just like y1, the x coordinate of the point that you're thinking about passing through, you can replace the x coordinate into here. This x does not change. So this is what we call point slope form, because literally the y point, x point of a coordinate are here, as well as the slope. So that's why we call it point slope form. Point slope form. Okay, so these are two. In this particular section, these are two tools we're going to use to solve problems like this. So let's go ahead and create. You don't have to draw this perfectly to scale, but you should still draw it. I'm going to draw just a rough set of axes, and I'm going to kind of just create intervals that are evenly spaced on each side of the axes. It's not going to be perfect by any means. 2, 3, 4, 5. I'm going to do 5 tick marks. 2, 4, 5. And this, they say that this circle is centered at -3, 1. So is at -3, so -1, -2, -3, and +1. So it should be here. That's the center. I'm going to say that's -3, 1. I know it's hard to read, but I'm going to write that so I can see for myself. That's -3, 1. And then there's a point on this circle at 1, 4. So that's here, 1, 4. So that's going to be up here. So that's 1, 4. And then I know that that's a circle, so that's going to be a radius that is equal to 5. And then I'm going to draw a circle that's, I'm going to try to draw like a symmetrical circle. I failed miserably, but hey, hopefully you get the idea that it's supposed to be a circle, okay? With a radius at 5 at any radii, all the radii should be 5 from the origin to any point on the circle, okay? So now we're talking about a line that will hit only this point, 1, 4. That only hits one point on the circle. In this case, it's 1, 4. So I'm going to draw it here. I'm going to make it a little bit bolder. Okay, we got to find the equation for this line. What is the equation for this line? So I don't know. But I could say this. Here, we can find the slope from here to here. And also, anything that is tangent to the circle creates a right angle with the radii that extends from the origin to that point that is tangent. Okay, so we know that they're perpendicular to each other. So I know that if I try finding the solution, or I try finding the equation in the form of my slope-intercept form, I can actually find the m part, the slope of this line. How? Well, I can find the slope of this line extending from the center of the circle to the point on the circle here. And then I know whatever slope that is, if you take the negative reciprocal of it, you will find the slope of the line that is perpendicular to this radius, which would be this right here. So let's try to find just the slope. This slope here from here to here, let's do that. That's a slope of rise over run. Again, you don't have to write this, but it would help. It'd be y2 minus y1 over x2 minus x1. That'd be, I think let's make this my x2 and my y2. It'd be 4 minus 1 divided by 1 minus -3. That'd be -3, or that'd be positive 3 over +4. So that's the slope of this line. In order to find the slope for this line now, which will help us to find the equation for this line, the slope's going to be the negative reciprocal for this. So here, our slope's going to be this, only flipped, and the negative version of it. So there we go. We just found that by taking the negative reciprocal of this, we have found the slope of a line that is perpendicular to that radius. Okay? So that's -4 over 3. I don't have a b, but if you notice, the point slope form still lets us use at least one point that we have on this line, which happens to also be that one point that is touching the circle, that is on the circle, I mean. And we have the slope. So using this guy, we can create the equation for this line. So it'd just be y minus 1, 4, so it'd be 4, the y component, is equal to, -4 over 3 times x minus the x coordinate, which is 1. Okay, that looks pretty good, all right? But if I were to work this out even further, it'd be -4 over 3x minus, or plus 4 over 3, -1. That -4 to 3 distributed to the -1 creates a positive 4 over 3. Everything has a denominator 3, so I'm going to make this in terms of 3 by multiplying this times 3 over 3, which would be y minus 12 over 3 is equal to -4 over 3x plus 4/3. I will add 12 to both sides, 12 over 3 to both sides, and the final equation should be y is equal to -4 over 3x plus 16 over 3. That is the final equation for this line. So I think possibly on the AP test, they're going to look for something like this, just to see some small little algebra, but I would say that you could actually stop here. This would probably be the safer bet, because you're not going to do any algebra that makes this incorrect or any wrong errors here. Okay, so that's how you do this. Hopefully this kind of puts together what we at least just got to discuss about in class. I'm going to go ahead and stop. I'm going to do one more topic on 1.1. Okay, little sneak preview. It's going to be on composition functions. I'm going to go through this in the next part. So thank you for watching, and then we'll see you then.